Hello everyone, in this video I am going to explain how to convert NFA with null transition to NFA and DFA. For this I will be taking some example. Now suppose I have this NFA given. NFA is converted into DFA and NFA. This is NFA null. So remember this NFA null has two symbols, that is A and B, as well as union with null. So for this, again make the table. There are three symbols here now, A, B and null. Q naught on reading A, just map the diagram into the table. It's going on Q naught. Q naught on reading B is going to phi, that is Q naught doesn't have any transition on B. Similarly, Q naught on reading null is going to Q1. Q1 on reading A, it doesn't have any transition on A, so therefore phi. Q1 on reading B is Q1. Q1 on reading null is phi. Again, when we are converting this NFA null to NFA and DFA, we need two more columns. As there are two symbols A and B in the sigma, take the extended transition function of the states Q0 and Q1 for symbol A and extended transition function of the states Q0 and Q1 with the symbol B. For this, you need to remember, if you have gone through the extended transition function concept, I have already discussed this delta star for NFA. See, this delta star for NFA, if you remember, is given as Q comma YA is the union of R that belongs to delta star Q comma Y, delta R comma A. Please do watch the video for extended transition function of NFA. And once we know the extended transition function for NFA, we can compute just by following the null closure of the equation 1 to get the delta star of NFA null. So we have already discussed null closure concept also in the earlier videos. So just follow this. Now I will start with filling up this column. Delta star with Q comma A, delta star Q comma B. We'll fill up this column by using the formula in equation 1 and 2 respectively. This is equation 2, this one. Okay, now you know what is extended transition function of NFA null. We'll start solving this question. First of all, find delta star Q naught with A. It is equal to null closure of delta union of R that belongs to delta star Q naught comma null delta R comma A. Remember, whenever we have Q naught A, just take it as null followed by A. Null followed by A. So now we have to know what is delta star. Delta star Q naught null. If you remember, null, this is the base case for extended transition function. Q naught on reading null string will return you the same state, that is Q naught. And since we are working on the extended transition function of NFA null, we need to find out the null closure of Q naught. Q naught, the null closure of Q naught is Q naught only, then followed by, see the path going, taking the null input. Q naught on reading null is going on Q1. So Q1 is included in this set. Now since there is no null transition on Q1, so we will stop here. So Q naught Q1 is the answer for delta star Q naught A. It is Q naught comma Q1 for this. So I will write it in this way. Null closure of union R that belongs to delta star Q naught null is giving us answer of Q naught Q1. This is delta R comma A. Replace the value of R with Q naught and Q1. So I'll get null closure of delta q naught comma a union delta q1 comma a. Now see the diagram. Q naught on reading A is going on Q naught. Q naught on Q1 on reading A. Q1 on reading A is phi. So the answer is null closure of Q naught. Now again, null closure of Q naught, we know it's Q naught, and see if there is any null transition on Q naught. Yes, it is having a null transition and it is going on state Q1. So Q1 is included in set. So delta star Q naught A is Q naught Q1. We'll repeat the process for delta star Q naught comma B. So it is B here. Repeat the process. Q naught on reading B and Q1 on reading B. Find out the null closure of this set. Q naught on reading B is phi. Union with Q1 with reading B is Q1. We need to find out the null closure of Q1. Q1 doesn't have any null transition. So the answer is just Q1. So I will write Q1 here. Now we need to repeat the process. So sorry, B. Repeat the process for Q1. The state Q1, that is extended transition function of Q1 with A and with B. So what will be the process? Again repeat this. Q1 on reading A. So read it as null A. It is Q1 delta star Q1 null R A. So Q1 delta star null. Remember that extended transition function for any null string is Q1 only. That is the same state. And find out the null closure of Q1. Null closure of Q1 is Q1 only. This is Q1, and since there is no transition of null, so it remains Q1. So I get Q1 here. This state is Q1. This set is Q1. So replace R with Q1. I'll get delta Q1 comma A. There's only one, there's nothing to be union with. So therefore this is Q1 on reading A is giving us phi, and null closure of phi is phi. So I get phi in this place. Similarly repeat the process for symbol B. So Q1 on reading B is giving us Q1. Null closure of Q1 is Q1. So we have completed the table. Now how to make the diagram out of this table? What we need to do, we need to just follow these two columns. Just follow these two columns. Now start with the initial state. The initial state of NFA null remains same in the initial state. I am just making NFA here. NFA null, the initial state of NFA null remains same in the initial as the initial state of NFA. This is the initial state. Also the initial state, that is the final state in the main diagram. If it is here, it also has the same thing, that is the final state in the main diagram is also the final state in the NFA, equivalent NFA. So this is Q naught. Q naught on reading, just see this, Q naught on reading A is going to state Q naught and Q1. So therefore Q1 was also an accepting state there, so make this as the final state. So Q naught on reading A is going to state Q naught and Q1. See this. Similarly, Q naught on reading B is just going to the state Q1. Q naught on reading B is going to state Q1. Now Q1 on reading A is 5. It means we do not have to show any transition of A on Q1. Q1 on reading B is going to the state Q1. So this is the equivalent NFA for the NFA null. Now we will make DFA from this diagram. Start from Q naught, that is the initial state. As Q naught was the final state in the main diagram, I'll also make it a final state here. Q naught on reading A is going to some state Q naught Q1. Name it as Q naught Q1. Remember that Q naught as well as Q1 was the final state in the main diagram. If any of these element in this subset, if it is mean, that is final state in the main diagram, I'll make this as the final state. Also, we need to see the transition of Q naught on reading B. It is going to state Q1. Make this also a final state, as Q1 is the final state in the main diagram. Okay, now we have to see the transition of Q1. Q1 on reading A is going to some state phi, and make this and state phi. Once you make the state phi, remember that phi is on reading A or B, it stays there only. Q1 on reading B. Q1 on reading B is going to state Q1. So it will make a loop like this. Now we have this state Q naught Q1. Now for Q naught Q1, whenever we have a subset with more than one element, be careful. What we need to do, check all the rows with these elements. There are two rows, Q naught and Q1. See both the rows. What you need to perform, see this column. This column is for what symbol? Symbol A. So Q naught Q1 on reading A, perform the union of these two rows. For that is for row for Q naught, it is having the value Q naught Q1, union with Q1, the value which is there with Q with respect with row Q1. It is 5. So I'll get Q naught Q1. So Q naught Q1 on reading A is going on the state Q naught Q1. Similarly, now perform the union of these two rows. Q naught Q1 on reading B is going to Q1. So this is the DFA for the given non-deterministic finite automata with null transition. I will be discussing more such example to convert NFA null to NFA and DFA. Thank you for watching.